Hello everybody, welcome to week 6 of BinaryTree's comprehensive curriculum, and welcome to programming. Today you'll write your first real code. We're learning Python, one of the most popular and beginner-friendly languages in the world. We'll cover how it works, its core data types, variables, and conditionals, and you'll write actual programs in BinaryTree's online editor. No experience needed. Let's begin. We're starting off with a quick recap of last week. Last week, we looked at web development, what makes a website objectively good or bad, and how HTML, CSS, and JavaScript work together. This week, we go from describing websites to actually building programs. Our focus is Python's syntax, data types, variables, and conditionals. And our goal is to write your first programs right in BinaryTree's online IDE. So what is Python? As I'm sure a lot of you already know or have heard of, Python was created back in 1991 as a high-level general-purpose language, and it's become one of the most popular in the world, mostly because it's so readable. Beginners pick it up quickly, but professionals use it at the highest level. It's fantastic for automating repetitive tasks, and it plays a huge role in machine learning, and it's everywhere in the industry. Google, Netflix, NASA, and Instagram all run on Python. Let's get you set up to code. An IDE is just a program where you write and run your code. It's an interactive development environment, and there are online and desktop options. For this course, we're using BinaryTree's own Python IDE. The best part is that there's nothing to install. Just open your browser and go to binarytree.us/ide.html. It opens right there in your browser, ready to code. Go ahead and pull that up now. 3 things make Python special. First, libraries. Python has a massive ecosystem of pre-built tools. PyTorch for machine learning, Pygame for games plus math, requests, pandas, and thousands more. Second, community. One of the largest in the world, which means almost any error you'll ever hit already has a solution online. And third, syntax. No curly braces, no declaring variable types, just clean indentation and colons. It's simply easier to read and understand at a glance than Java or C++. Now, Python isn't perfect. It trades speed for readability. Here are the main reasons why it's slightly slower. Python uses an interpreter, which executes your code line by line at runtime, converting each line to machine code as it goes. It also uses dynamic typing and automatic memory cleanup, which add overhead. C++, by contrast, uses a compiler that converts everything to machine code before running and optimizes along the way, with static typing and manual memory control. C++ is closer to the machine, so is faster but far less forgiving to write. So for a quick discussion, let's think critically. Because Python has more forgiving syntax than Java or C++, does that make Python more efficient overall? Explain why or why not. There's no right answer, just explain what you think. Write it down on a piece of paper, pause this video, and unpause when you're ready to hear what we think. In our opinion, it's not necessarily. Easier syntax makes Python faster to write and learn, but that same flexibility actually makes it slower to run than C++. Efficient for the programmer isn't the same as efficient for the machine. But now let's move away from theory. Let's get into the actual fundamentals of how to write the code. First, let's look at data types. These are the types of kinds of information Python can hold. Look at the code on the screen. We have numeric types, an integer like 42, and a float like 3.14 with a decimal. We have a text called a string, which is always wrapped in quotation marks. We have a boolean, which is simply true or false, and we have sequences, a list written in square brackets which you can change, and a tuple in parentheses, which is fixed. Those are the core building blocks of every Python program. Next, let's look at variables, which are basically just containers that store data. The beautiful thing in Python, you don't declare a type, you just write the name, an equal sign, and the value. On screen, my underscore name, the variable, holds text. Age holds a number. Now notice the idea of scope. A global variable defined outside any function can be accessed anywhere, but a local variable defined inside a function only exists inside that function. Scope simply answers where in my program can this variable be seen. Time for the classic first Python program. The print function displays something on the screen. Print, then in parentheses, hello world, exclamation mark in quotes. You can also print a variable, and here's the key rule. Put quotes around text, but do not put quotes around a variable name, or Python will print the name literally instead of its value. You can even print multiple values separated by commas. Simple as it looks, print is how your program talks back to you. Your first coding task. Store the hello world into a variable, then print that variable. Give it a try in the BinaryTree IDE before you look at what's supposed to happen. And here's the solution. Create a variable called greeting. Set it equal to hello world in quotes, then bring greeting with no quotes and print it. One quick note on the slide. Use double quotes for strings. Single quotes are reserved for single characters in many languages. Now let's make programs interactive with the input function. Input pauses the program and waits for the user to type something. On screen, we ask, "What is your name?" and store the answer in a variable. But here's the critical catch. Input always returns a string, even if the user types a number. So if you want to do math with it, you have to convert it first, using int for a whole number or float for a decimal. Miss that step and your math will break if you're using the input value or variable to do some kind of computation. Now let's do some math. Python has the operators you'd expect: plus, minus, times, and a few special ones. A single slash divides, a double slash is for division, which drops the decimal. The percent sign is modulus, which basically gives you the remainder when you divide the two numbers, which is super useful for checking if something is even or odd. And 2 stars is exponent. So 10 double star 2 is 10 squared. There are also shortcuts called assignment operators. X plus equals 5, which just means x equals x plus 5. Small tools, but you'll use them consistently, and they can make your code a lot easier to read and a lot more efficient to write. Now for decision making. We have if-else conditionals, which let your program choose different paths. Read the logic on screen. If the number is greater than 0, print positive. Elif, short for else if, checks the next condition, less than 0, and prints negative. And else catches everything left over in this case, which would be 0. 2 things to notice. Python uses that modulus trick to check even or odd, and the indentation itself defines each block. In Python, whitespace isn't decoration, it's the fundamental structure. Now let's combine everything. Your task. Using arithmetic and if-else, write a program that tells whether a number the user enters is even or odd. Think about which operator finds a remainder. Pause the video and try to code it on your own. Here's the solution. Read the input and convert it to an integer. Then, if the number modulus 2 equals 0, print that it's even. Otherwise, print that it's odd. We can encode this logic with an if-else statement. Try it yourself first, then check against the slide. Let's wrap everything up and recap what you've just learned. Python is beginner-friendly and high-level, but powerful enough for professional work. Its simple syntax makes it accessible, though it trades some speed for readability compared to C++. And today, you covered a lot: print, input, variables, data types, operators, and if-else conditionals. That's the real foundation of programming. Everything else builds on it. Next week, we go further into data structures and libraries. And that's it for week 6. You went from zero to writing real interactive Python programs today. That's a genuinely big deal, so nice work. Next week, we level up into intermediate Python. Lists, tuples, dictionaries, and libraries, the tools real programs use to manage data. Hope you have a great time and see you then.